I'm delighted to start 2026 off with one of my colleagues and friends, John Krosnick. As you'll see on the screen here, John is a professor of basically everything here at Stanford, and there's really good reasons for that. When I was at Cornell, I was on the advisory board for the Survey Research Institute, and John may not remember, but I advocated for a couple of years to get John out to be our big keynote speaker at Cornell. There was one every year, and of course, John came out and gave a fantastic talk. Since coming here, John's been a great colleague. We've had a lot of opportunities, and I think the best compliment I can give John is that for my PhD students, there are two types of students. Those that have taken John's survey methods class and those who have not. And the ones who have become different and better researchers, and given how much even those of us that do behavioral research now use survey instruments to get our data. John's research and his teaching is absolutely crucial. And he works, in addition to the method side of things, on some really crucial topics that are relevant to our community. So please join me in welcoming Professor Krosnick.
Well, thank you for your time today. Thanks for the invitation to be part of this series. I was instructed to speak into the microphone, so I'm going to try to do that on behalf of folks who are joining us remotely. So fantastic to have this community of tech-oriented researchers on campus, and it's, for me as a member of the Stanford community, you all are one of the reasons I'm proud to be here. So thank you for the opportunity to share my work with you. This story that I want to tell you today is one that has a punchline that is absolutely not new. It is decades old. And in fact, I'm going to start with the punchline and tell you where I'm going to go, because the adventure, the story itself, the ups and downs, is pretty instructional about where we are at the moment and what life is like professionally. So I don't know how many of you would remember seeing this image, but this is Harry Truman when he was elected president of the United States, proudly holding up the Chicago Daily Tribune front page saying, Dewey defeats Truman in the presidential election. That the headline, of course, not correct. And you can see Truman quite happy about that. Here are three people who also seem to be happy. Archibald Crosley in the middle, George Gallup on the right, Elmo Roper on the left. They are the three men who were responsible for that incorrect headline. And the reason that they were responsible for the incorrect headline is that they were the three leading pollsters in the country. And all three of them in their final pre-election polls, as you can see, said that Dewey would defeat Truman. And if you were the Chicago Daily Tribune, you would say, okay, good, we can produce a headline before everybody else based on this obviously solid scientific evidence. As you can imagine, after that headline, those three guys were not smiling so much anymore. And the lesson that we learned subsequently is that the method of survey data collection that those three used, the leading national method, was vulnerable to this very error that we saw. But at the same moment, it turns out an academic group, those three were commercial pollsters, an academic group, these guys, Phil Converse, Warren Miller, Angus Campbell, and Don Stokes, launched in that same year the American National Election Study at the University of Michigan, which used a different method, and this is what they got. They got it right. And so the story I'm going to tell you today is about how we are relearning that same lesson right now in the context of technology and in the context of money. But let me just show you that this was not an isolated incident. The American National Election Study, which is now co-directed by Stanford and the University of Michigan, has shown levels of accuracy like this over time. So this is the percent of votes that the government says went to the winning candidate in the presidential election in each of these years, and the percent of ANES respondents who said they voted for the winning candidate. And you can see that these lines move together beautifully. The key here is that the American National Election Study at that time did random sampling of the American population. And you can think about random sampling as flipping a coin. It's not really flipping a coin, but if you imagine that a coin is unbiased, and for each potential member of the country, we were to flip the coin and either select them or not based on how the coin turns up. That's random sampling. And that's what has led to this track record for the ANES of accuracy over time. And so this guy, who is actually the hero of today, in addition to the four who you just saw, this is Willem Saris. And this whole story is about how smart he was in the 1980s. And Willem's adventure began by falling in love with political science, political psychology research being done by Milt Lodge at SUNY Stony Brook. Milt was doing something innovative at that point, borrowed from psychology. He was doing laboratory experiments to understand how people reasoned about politics. So out on Long Island, he brought people into the lab, had them sit in front of computers and read information and do tasks. And Willem just thought this was fabulous. But it seemed silly to him to do it just with people who would come to a lab at Stony Brook. And so what Willem did was to go to the Netherlands with technology. And this is the technology that he brought. Not only a Commodore 64 computer, but I don't know what the correct name is, but I call it a suction cup modem on the right-hand side on a telephone. And his idea was this, that the Netherlands is not such a big country. He could get a list of all the addresses in the country. He could randomly select a group of addresses. He could go knock on the doors, and he could offer people in those households this equipment as a gift from the University of Amsterdam if they would join a survey panel. And what that meant was every week they would put their phone into the suction cups and they would connect the computer to a server, and that would administer a questionnaire for them. So words would appear on their TV, on the computer screen, and they would answer the questions that were provided to them. So the innovation here was machine, no interviewer, and self-administration with a random sample. And that methodology was brought to the United States by two Stanford professors, Doug Rivers and Norman Nye. And they created a company called Intersurvey right near here. And the idea was to, instead of doing the going to doors and knocking on doors, at this point, they made random digit dial telephone calls. So think of that as flipping a coin and calling telephone numbers randomly, inviting people to join a survey panel, and providing to them web TV equipment. I don't know if you know what web TV equipment was, but essentially it was a way of adapting television to use a phone line, and again, got a little keyboard and you filled out questionnaires in that way. So this is what the web TV stuff looked like. You can see the keyboard and a little box that it was connected to, and a TV displaying questions. So they created something called the Knowledge Panel. And the Knowledge Panel started with this company called Intersurvey. Somebody decided that was a stupid name, so they changed it then to Knowledge Networks. And then Knowledge Networks was purchased by GfK Customer Search, and then it was purchased by Ipsos, and now it is the Ipsos Knowledge Panel. And over time, their recruitment shifted from RDD telephone calls to mailed invitations that show up at randomly selected households. And the web TV equipment was converted to computers. So the households that didn't have computers were given computers if they needed them. Now, essentially, no households need it, so the technology is kind of already there and ready to go. So how well does this technique work? Well, I want to show you the first bit of comparative data in a study done by David Yeager when he was here at Stanford. He's now a superstar at UT Austin. And David led analysis of a very large study, and I'm going to show you just a little piece of it. These are two accuracy scores comparing measurements of for example, do you have a passport? That's a question. And you can compare the percent of respondents who say they have a passport to that calculation based on State Department figures. And if you look at the absolute error there, you get a sense of accuracy. And he did this for not only for the Knowledge Panel, but also for a random digit dial telephone survey at the time, which was kind of the standard, affordable, high-quality method. And you can see on the left-hand side that the average absolute error, how far off was each percentage from the truth, was for the random digit dial telephone survey about 3 percentage points, and only a hair higher for the Knowledge Panel. So here, the cool thing is when you make a phone call to somebody, then you do an interview, and you get as much information as you can before they're not willing to stay on the line anymore, and that's the end of it. Whereas once you set up a panel and you've got households ready to do weekly surveys or even more often, your investment in setting them up pays off dividends with repeated data collections. The more important, I think, revealing way to look at the data that I'm showing you here is this. This is the frequency of errors. So in each of these graphs, as you move from the left to the right, the error, the difference between the truth and the survey measurement gets bigger and bigger. We don't want anything over on the right-hand side. We want only things on the left. In fact, the happiest graph would be one where the leftmost bar at 0 is the tallest, and there are no other bars. And as you can see here, the internet data actually are more compacted to the left than the telephone data are, that they are more reliably accurate in producing those desirable numbers. So this is when things take a turn. A bunch of clever business people say, you know, that's so expensive. I think there's a way to do this more easily and effectively. And that is, we don't need to do this random sampling. We don't need to make the recruitment phone calls. We don't need to send out invitations to randomly selected households. We can just put up billboards on highways and offer people the opportunity to volunteer to sign up for these panels. And if we pay them enough, then we can get lots and lots of responses. And you know what? When we talk to the people at Coca-Cola, and I'm not picking on Coca-Cola in particular, they're a metaphor here. When we talk to the people at Coca-Cola, they mainly want 1,000 respondents. They're not all that hung up on who the respondents are. So let's just give them 1,000 people. So the even better idea was to abandon random sampling entirely and to use the internet as a device to get data quickly. So this non-scientific sampling method involved allowing people to sign up for surveys for money or points or credits of some kind. Recruitment was done not literally through billboards on highways, but through banner ads on websites, invitations while people were doing something else online, invitations often at the end of other interviews, lots of different ways. And samples were weighted and balanced to resemble the nation, maybe in terms of some demographics with some quotas on the invitations that were sent out and post-stratification after the data were in. And sometimes fancier things were done like propensity score weighting and matching. The response rates for these surveys have always been well less than 1%. So just bear that in mind. Like if you want to get 1,000 responses, you have to invite 200,000 people to do it. Because these are not people who committed to do, they volunteered to do surveys. I'll get an invitation, either I'll do it or I won't, depending on how I feel at that moment. And by the way, they don't pay much. I pay 60 cents, $1.20. So what was said about this method after it was introduced? Well, I think the best moment of advertising for this method was in the New York Times. A feature article about this innovation in the survey world, in which one online opt-in panel company says it can predict election outcomes and consumer preferences with greater accuracy for far less money than ever before. That's a very strong statement, right? More accurate than ever. Or another such company said that their election polling results were as close or closer to the actual votes than traditional polling methods. I mean, this sounds fabulous, right? And a professor said the bottom line is that they get results as good or better than other polling agencies. The article didn't mention that the professor's son-in-law was the director of methodology for one of the companies, but okay. This is my favorite. This was an article in the magazine Campaigns and Elections called The New Polling Revolution, Opinion Researchers Overcome Their Hang-Ups with Online Polling. So forgive me for actually reading this because I think it's actually worth it. It's a truism that some of the smartest people throughout history, especially those who have profoundly influenced the way the world now thinks, were not always appreciated by their peers. Firm X, I'm going to keep them anonymous, has been engaged in research and development of online polling since 1998. Firm X's development of sophisticated internet polling methodologies, along with the negative reactions of some in the field, is nothing new and is in fact predictable in the world of scientific disciplines. After 9 years in research and development, Firm X has faith in their online methodologies because they have the results to prove its effectiveness. These results are the foundation for Kuhn's paradigm shift. Remember Thomas Kuhn? According to Kuhn, the strict adherence to any one theory, telephone methodologies in this case, represents an absolutely indispensable prerequisite for any paradigm shift. But once certain observations and data begin to contradict established theories, such as Firmex's online success in tracking the winners in so many 2006 U.S. Senate races, a controversy will arise in the field. These new results are first labeled anomalies, and as anomalies continue to develop, they raise questions about the basic validity of the established theory. Two competing schools will develop in a short time as old instruments, telephone polling, continue to fail, and old methodologies, telephone polling, cannot account for the same set of data. Kuhn's theory states that there is a shift from normal to extraordinary science, and these scientific developments necessitate the community's rejection of one time-honored scientific theory in favor of another incompatible with it. So that's a strong statement, written by the son of the owner of Firmex. Is this true? What was the evidence at that point to support the claim that this new non-random sampling methodology actually was more successful? So I'm going to tell you about an evaluation that David Yeager did. So this is made-up data. These are not real data. This is what you just read put in graphic form. So the claim here is that if we've got a series of companies providing data and we're measuring the accuracy of their measurements, and the taller the bar, the bigger the error. I've just shown you that for probability samples, the error tends to be about 3 percentage points on average. That's on the left-hand side. So then let's just pretend we've got a series of companies with opt-in samples to the right. Their bars are all shorter. They've got less error than the probability sample. Is that what David got? No, it is not. This is what David got. What David got is the opposite. What he got was the most accuracy came from probability sampling, and the less accuracy came from non-probability sampling. Look familiar? It should. It looks exactly like the first graph I showed you, right? It's the National Election Study in 1948 was more accurate than the leading non-probability sampling polls. But this is the more telling graph, right? So on the left-hand side, this is what I've shown you already, telephone and internet probability samples. And on the right-hand side is what you get from the non-probability samples. And the point is that the bars go farther to the right. There are more big errors. Now, if you don't mind making a measurement and being 39 percentage points off, then this is not a big deal. But that's, on the other hand, most people who are trying to do measurements care about an error of that magnitude. Oh, that was a long time ago. Things have gotten better undoubtedly since then, said the industry. So this is Bo McInnes's paper done here at Stanford with a similar design done years later. And what she saw is exactly the same thing. So just you'll see with the probability samples, the errors are the lowest on the left-hand side. And by the way, the folks who tell you, oh yeah, you know what, we've gotten better because we know how to weight the non-probability data. Let me show you now what happens to the errors when you weight the data. Well, a little better, worse, 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 a little better, worse, a little better, a little better. So it's not clear that the weighting is helping anything on the right-hand side at all, that statistical adjustment that's being made. And these are, again, the critical graphs, that the probability samples have the errors compacted more to the left than on the right-hand side, the non-probability samples, where they spread out. So when David's paper was published, there was a firestorm across the country. Tweets and panic in the industry, people saying, oh my God, we've been saying this stuff is better and it's not better. Stanford just put out a paper. And so the industry tried to deal with that, to cope with it. And one of the other heroes of this story is this woman, Kim Dedeker. Kim was director of market research for Procter & Gamble in Cincinnati. And she spoke the truth. She said, you know what? We were buying random digit dial telephone surveys for a long time. We make toilet paper and Kleenex and detergent, and things just don't change that much from month to month. And all of a sudden, when we buy these internet data, the numbers are bouncing all over the place. So she was really an important figure who then inspired the industry to acknowledge that there was an issue here, that they couldn't just brush the Stanford studies off the table. So SMR, an international organization of survey researchers, actually kind of confessed in 2006 in an important piece, after a period of relatively easy acceptance of the validity of online research, and by that I mean non-probability online research, clients have begun to ask some difficult questions about panel quality. Clients are asking more and tougher questions about the online panels that we use. which then led the Advertising Research Foundation, the professional association of commercial survey researchers, to try to defend themselves. They said, okay, here's what we're going to do. We're going to do the Stanford study, but we're going to do it ourselves. We're going to have lots of companies involved. We're going to do it the right way, and we will make the results public on January 27th. We're going to have a meeting in a room in New York City. People can be in the room by invitation only. We're going to have only one copy of the report on paper on a table on the side of the room, and people can watch the presentations online. And we'll describe the results of the study. So they did that, and they had their little conference, and they did not report any results. And they never released a report on accuracy of the surveys. Happily, a guy named Reg Baker, who unfortunately we lost a few years ago, who was a major force in market research, was under the tent of this, and he decided to leak the data. And so here's an example of one of the graphs that he leaked. And does it look familiar? Yes, it should, because it looks just like all the other ones, that they were disappointed to find that the errors were bigger for the non-probability samples than for the probability samples. Here's another example of the same type of thing from Reg. But this wasn't actually new, because in the Netherlands, a couple of young guys had run a study called NOPVO, where they got quite a few opt-in companies to do something similar to what David Yeager did here. And in this study, look familiar? It's kind of the same. The errors of the probability samples on the left are short, and the non-probability samples get bigger on the right. And most recently, Karina Cornice and others published this lit review of many studies like this, and Mario Caligaro and others published this book that are kind of reviews of many studies showing these same conclusions over and over again. So nothing has changed over the years. Nothing has gotten any better, despite the fact that every time a paper comes out, the industry says, oh, these data are 5 years old. Oh, these data are 3 years old. Oh, these data are from last year. No, we've fixed this problem. But there's no evidence that anything has changed. More importantly, it turns out you don't even need studies like this. You don't need benchmarks of truth to know that things are a little wacky in this world, because here's a very simple question. In the last 30 days, did you go out to see a movie in a movie theater? Okay? Now, this is before COVID, when we went to movie theaters, and this is the result from a probability sample, random digit telephone survey. This is not an error. This is 30% of people saying they went out to a movie. So I'm going to show you the results from 7 non-probability sample surveys. What? So, a couple of them over on the right side are kind of in the ballpark, but you got one company that said 82%. This is not unusual. This is typical. Here's another one. Did you see a movie in the last month? 55% in the probability sample, and these are the results for the non-probability samples. They're all over the place. So they can't all be right. They can't be highly accurate. Which brings us to 2016. Remember 2016, when you went to bed the night before the election and you were told Hillary Clinton had a 71% of chance of being elected president tomorrow by 5:38, or 85% chance of being elected president from the New York Times? Well, where did that come from? It came from an aggregation of surveys. What were the methods used for those surveys? Well, down here at the bottom is the little tiny red pie slice for random sampling. The biggest slice is on the right-hand side, online river samples. And those two, now random river sampling is a method of non-probability sampling that involves thinking of yourself as a fish. So you're swimming through the internet, and these researchers put in a net, grab you out for a second, and then drop you back in. The way this happened originally was you go to Google News, you click on a headline, it takes you to the Toledo Blade newspaper so you can read about the latest Beyonce record being released, and you read a paragraph, and then a box pops up, and it says, in order to read the rest of the story, please answer this question. Who are you going to vote for in the election on Tuesday? So then you answer the question, not necessarily accurately, and you go on with your swimming. So the two big purveyors of the river sampling data were Google Consumer Surveys and SurveyMonkey. Now, if you think about it for a second, it was a pretty ingenious method in the sense that the news media needed money, they still need money, And this was a way of taking a little tiny thing from people as they're swimming by and monetizing it, that of course Google and SurveyMonkey sold the data, and they thought they could go public with these data, predict the election outcomes beautifully, and then they'd have a bigger market for their product. So here's how Google marketed Google Consumer Surveys. They said, survey real people, get real answers. And this is what a question looked like. This little box would pop up and you would get that question and answer it and move on. And Google launched consumer surveys with this claim, saying that they were fast, accurate, and affordable. Now, if you've heard the same expression that I have, you've been told you can get 2 out of the 3. You can't have all 3. And it turns out that they did not get all 3 because, in fact, if you look at the errors, the biggest error is over on the right-hand side for the river samples. So, okay, so we'll skip that. Now, one last river sample finding before we close this door. Again, we don't need any benchmarks. Just compare the random sample results of 163 questions on a variety of public opinion topics across the 2 methods. This is the distribution of the differences between the random sample and the river sample. So again, all of these bars, there should be one bar that's really tall on the left at 0, but the gaps get really big. Now, if you're Google Consumer Surveys and you want to say, we are very accurate, all you have to do is cherry pick a few from the left. And you can say, look how for each of these questions, the percent giving a particular answer in the probability sample almost exactly matches the percent in the non-probability sample. But if you want to be honest, you could cherry pick awful items and you could have much bigger differences between them. Okay, so what happened in the 2016 presidential election? Well, when you divide up the surveys done during the last week, just the last week, with probability samples, the average error for the probability samples was less than 1 percentage point off in predicting the Clinton and Trump share of the vote. But remember, to accurately predict the outcome of the election, you don't need a survey in California. You know who's going to win in California. You don't need a survey in Texas. You don't need a survey in New York. All you need is very precise surveys in 5 or 6 battleground states to figure out what's going to happen there. And in those battleground states, in 2016, in the last week, there were about 70 pre-election polls done in those, one of them with a probability sample in Florida, with an average error of 1.1 percentage points. There wasn't the data. You can't average together a big pile of garbage and then get something other than a bigger pile of garbage. So the errors aren't random. There's no statistical principle that says more solves all the problems. So that's that story, but let me just show it to you graphically. So these are the little tiny errors for the probability samples on the left-hand side and the much bigger errors for the non-probability samples on the right-hand side. So, okay, 2012 comes, Google has to accept reality. So, guess what they did? They closed down Google Consumer Surveys. Not a minute too soon. And I think I can tell you this, when I was asked to visit Google and give a talk and meet with people, the supervisor way up in charge of Google Consumer Surveys, which before this moment, just loved it, just thought this was the greatest thing. And, who knew what was going to come from that? So, who's smiling at the end of the story? Willem Saris is smiling, because the truth is his method was a success in the Netherlands, and it's still a success today. Let me just show you that not only, it turns out when he started it, it was called the telepanel. That transformed into center data that now has the center panel and the mess and list panels. That same methodology is alive there. The knowledge panel here, I've shown you this slide already. But in addition, the RAND Corporation created their own called the American Life Panel. The University of Southern California created their own called the Understanding America Study. The University of Chicago created the AmeriSpeak panel. And they did, at the time, the most deluxe recruiting by face-to-face visits to randomly selected households and telephone calls and mailings to them. And then SSRS created one, and Gallup created one, and the Pew Research Center created one, and in fact, across lots of countries now, there are many, many knowledge panels. So, okay, this method, in a way, you might say, this is great, this is a good sign. science is winning, and it is in a way. But this whole slide is dwarfed compared to the gargantuan revenue and work being done with non-probability samples. You say, I'm an academic. I can't afford to pay for excellent survey data. I got to just go with whatever I can get. And it turns out the National Science Foundation has something you can't resist because it's free, and it's called TESS. So TESS is time-sharing experiments for the social sciences. NSF's been funding it for quite a few years. The idea is you write a little proposal. You have to be describing an experiment, but you put into this experiment some manipulation. And if it's funded by them, they collect the data for you. You go to the Bahamas, have a beach vacation for a couple of weeks, and then you come back and the data are in your inbox. So, and it costs nothing. Now, Bahamas cost something, but okay. So the indisputable truth I'm going to end with is if you draw a random sample from a population, you can generalize every attribute, whether people like chicken more than steak, whether they have size 9 shoes, whether they have red hair, whether they vote for Republicans, it doesn't matter. The great thing about randomization is every characteristic matches. And so the coda of this talk is maybe what you're thinking about, which is, but what if the response rate's less than 100%? Well, it turns out the response rate's always less than 100%. This is just an example of decline over years in the response rate for a series of telephone surveys since January 1996. And these are declines in response rates for major federally funded surveys. Response rates have been going down for a while. And the question is, does this reduce accuracy of surveys? And the answer is, amazingly, it does not. There are quite a few publications now, which are listed here, that all show that if you start with a truly random sample and you work as hard as you can to get participation from everybody you can get, even when the response rate is as low as 10%, that the accuracy is as good as I showed you. In fact, those accuracy figures come from surveys with very low response rates. So if you want to criticize surveys, you can try to point to response rates, but remember, the non-probability sample response rates are way smaller. That is not a device to defend those surveys if you want to say you need a higher a response rate to be better. Here's the last slide. This is just to show you most powerfully. These are the average errors in pre-election polls by major organizations between 1936 and 2004. And what you can see is over the years, accuracy has gotten better over time. Now, there is this little bump up there in 1948. That's what I showed you before. That's where we started. And before 1948, of course, those are not probability samples. After 1948, people woke up and realized. And they are probability samples. The important thing is the lowest error here is in the year with the lowest response rate. It's just not a debilitating problem. Okay, so what conclusions can we reach? Saving money is great, but not at the expense of scientific accuracy. And we can't afford to compromise scientific accuracy right now. You know, science is being attacked left and right for political reasons. And then again, there's the self-imposed replication crisis that we're dealing with. With all of that in mind, the last thing we should be doing is overclaiming. The last thing we should be doing is collecting data that don't justify a claim of accuracy. Because on election day, they're going to find out. So all I ask is that you think about these issues and that you never claim in your data anything other than what's honest about what they are. And here's the most tempting word to use, representative sample. People use that term to say, well, I had about the right percent of males and highly educated people and a couple demographics as if that makes it representative of the country. It doesn't. Don't use that word, please. Just say what it is. Just describe what you did. Science can progress ahead with non-representative samples in big. Psychology as a discipline has made decades of fabulous progress with studies of college students. We can learn a lot about people without overclaiming. And I think we get ourselves into trouble when we do. Thank you very much.
Thank you so much, John. What a great story, and that Stanford plays a pretty big role throughout it. I wanted to start with a couple of basics. Accuracy. So when you're showing all of the graphs in which here's how accurate or how much error there was for each of the things, in things like elections, I feel like I can understand that. Here's the data from the government, and we can compare. You had some other things up there, and what many people ask questions about, like how many cigarettes did you smoke in a day? And you were showing accuracy numbers. So how do you get ground truth, or these, you called it benchmark truths? Where does that come from for most of these things?
Yeah, so in the biggest studies most recently, there are as many as 40 or 50 or 60 benchmark variables. And so they're all variables that are benchmarkable. And what do I mean by that? Well, you got to have some standard of comparison. And the easiest one is some truth. So for example, the State Department knows how many people have a passport. And you can ask, do you have a passport? The state governments know how many people have a driver's license. You can ask, do you have a driver's license? You might think of voting as being like that, right? The government tells us how many people voted for Donald Trump, but you also know that's being disputed these days, and you also know that when you do a survey and you ask people, who did you vote for president yesterday or even today, the best they can tell you is who they think they voted for, right? Because after a ballot is cast, it's routine for government officials to invalidate some ballots. For example, if you vote for two candidates in a race instead of one on a paper ballot, which are being used a lot, that invalidates the ballot. So you, the voter, don't get told your ballot has been invalidated. So we should just bear in mind people have a limit to what they can know. And frankly, it may be more interesting to know who people think they voted for or who they wanted to vote for than who the government thinks they voted for. So there's a little looseness there. But then there are questions like how many bedrooms are in your house? Now that's presumably a fact, although is that room, I mean, we are using it as a bedroom, but it was actually meant to be a closet, and, you know, I mean, I'm sorry for my son, it's a small room, but, so that's, there maybe are sub-judgment calls, but there are federal surveys with nearly 90% response rates that ask that question. Those are also sources of benchmarks. So either they're high response rate federal face-to-face surveys or they're official statistics.
Okay, so you can use official statistics to get that. Let me ask about a different kind of accuracy then. When you were talking about the river sampling, you said I had throwaway, which is like they had to answer their thing before getting back into their internet swimming. And you said maybe not even accurately. So I wanted to get a sense from you, is some of the problem of river sampling in these panels is about participant accuracy, like they're satisficing or something like that? Or where is all this like gigantic error or the garbage coming from? Is it purely because it's non-random sample, or do you have some suspicion that there's like less accuracy of people actually responding accurately on the survey?
Yeah, so there certainly are concerns about if somebody has signed up to do surveys for money and they know they will get paid the money if they complete the questionnaire, the quicker they get through this questionnaire, then the quicker they can go to the next questionnaire and the next one, and then by the end of an hour while they're watching TV after a class in the afternoon, they can get through quickly and make a little bit more money as a result of not being careful. So that's one scenario. Unfortunately, there are horrific scenarios that we're now learning about, which involve what are called click farms in countries where people are paid very little to work per hour, and as long as you hire a room full of people to sign up for these surveys, to use some technique to appear that they're in the US as opposed to where they are in some other country, and to then not even bother reading the questions, just clicking through, they can make money. AI technology is now being used to pretend to be respondents, but your question, Jeff, is about real people.
Real people.
You know,
Yeah.
So first of all, we got to get rid of the junk, and that's hard.
Yeah.
The cool thing, by the way, just remember the whole story I just told you. Probability sampling starts with a person. You know, you are starting with a real person, and so the difference between the signing up, which can be done by a bot or a click farm, versus I went to your household and I asked you to join my panel, you've got a certain protection that's happening right there. Mm-hmm. And you create a relationship with these people. You know, they know who you are. They know, in fact, the panels are notified about the press coverage of the results of surveys from their panel. They know they're participating in something that has real consequences. So I think by setting up that kind of relationship, that may enhance people's dedication to being
That makes sense to me, because something else I was seeing in some early data that I was working on showed that internet random sampling can be more accurate than telephone. And so you're not saying that there's something about like being on the internet makes you less honest. It's just like you're forming a relationship. When they're in text, maybe they're more honest because there's less stigma or whatever. Okay.
Yeah, so I didn't tell you about Lin Chat Chang's experiment in which she randomly assigned people either to do interviews over the phone or to complete the very same questionnaire on a computer. Computer did better in every way.
Right, because they're not having to like face a person and deal with their responses. And all that.
They can go at whatever speed they want. They can read and reread a question as many times as they want to. The whole series of advantages.
Okay. I'm going to bring up, you mentioned AI for a second. I'm going to take this opportunity to selfishly ask you a bunch of questions about that. So one of our projects, we found that about 30% of the participants from a crowd, online crowd.
Participants.
Yeah, right. 30% were not human.
Yeah.
And I mentioned this to John earlier, and he's like, that is now typical. And so there's about to become a giant crisis in social science because all labs now rely on this. You know, I have the social media lab just a few doors over, but we hardly ever bring people down to the lab because it's expensive and time consuming, et cetera. So what are the emerging what's the emerging consensus, John, of like the scale of this problem? And then second, are there developing some best practices that the students and researchers in the room can draw on?
Yeah. So just another boost for Stanford. A paper was published maybe a month ago by Sean Westwood, who's a professor of political science at Dartmouth, basically demonstrating that he was able to build an AI bot that could pass every test and every test that survey researchers were using to try to find bots, his bot passed them. Plus, he could tell the bot to answer questions leaning in a liberal direction or leaning in a conservative direction. So this sounds like the death knell, basically. And so there are some companies that are using these opt-in surveys that are potential victims of this who say, no, it's no problem. We got this figured out. We've got all the protections in place. So it's only a matter of time until Sean has his bot go after those companies, and then we'll see what happens. But at the last American Association for Public Opinion Research Conference in last May in St. Louis, there were companies that were demonstrating this 30 to 40%. They showed you how they could see how crappy the samples are. And then there were other companies that said, now, did you see that presentation earlier? I'm your savior. I'm here to protect you. We have fantastic techniques to catch and get rid of those fake pseudo-respondents. Not one shred of evidence that it was actually, they got rid of people, they got rid of answers. There was not a shred of evidence that they were not real respondents and that they got rid of all the not real respondents. That it's just not, it's not there. But you could pay money to them, and you know that might make you feel a little bit better. But you figured it out somehow. Right. And however you figured it out, that's really important. That's the first step.
It was time consuming / embarrassing because when we had to pay people, there was some weirdnesses happening. I don't know if we would have spotted otherwise.
Yeah, good.
Okay, then.
Sell that.
Yeah, right, exactly. So I'll turn it over to the group here in a second. But my last question then is like, okay, obviously these more expensive panel-based things are the way to go for like real accuracy, and maybe will be necessary as we move into this next era. What's like the cost differential for a 1,000-person study? Let's say it doesn't even have to be fully representative, but I just want real people. I might be running an experiment, say 1,000 people. What's the difference between doing it just with an opt-in versus an actual panel?
Okay, so I'm going to give you the honest answer first. Think about the astronomers. They're using a telescope in Arizona to study stuff far, far away. What's more important? The gazillions of dollars that they spent on that, no dissing against astronomy, versus what we're doing. It's a tiny, tiny fraction of that. And what we're talking about when you build a panel is to build a telescope and then let all the researchers share the telescope, which is exactly what the astronomers do. Our cost is tiny by comparison. The problem here is not that we have limited budgets. The problem is that we are not screaming to the world that we have limited budgets and we need bigger budgets to be able to cover the actual costs. So I will tell you a little dream that I have when I go to bed at night sometimes, which is we're heading into an election and then another election and another election after that. And you know there are going to be voices saying the election was stolen if it goes in a particular direction. How can we try to prevent that? Well, what we need is lots of high-quality pre-election polls that say result, 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 so that on election day, nobody's surprised by how it turns out. And how much does that cost? It turns out, according to people who have money, that's all? Oh, we can afford that. The problem is we don't say to the funding agencies, look, this is why, and just bear in mind, when COVID happened, it was really clear. We needed vaccines, we needed medical research, but we also needed research on human behavior. And lots of that work was done. All of a sudden, oh, we need that. We need to make the case that we can do it. And the question is, how do we afford it, is to get the budgets up.
Okay, so thank you for your honest and perspective shaping answer, but what's the real number?
Okay, so if there were a real number, I would happily share it with you.
Yeah.
And now let me take the opportunity to do an ad here for the Stanford Institute for Excellence in Survey Research, SIESR, CSER. Could we just all together, one, two, three, hail Caesar? Ready? No, I'm kidding. Okay. So this is a very exciting new institution on this campus that is designed to help both survey research at Stanford and survey research in the world. And one of the things we want to do is try to answer your question, because there are no posted price lists. Every study is negotiated with the sponsor. And frankly, lucky for us, we're academics. And it turns out they love doing work with us. So they will reduce prices when you have an exciting study that you're going to do. So you priced a study that's very big recently, and you know what that cost. Yeah. But if we tried to price that same study here or in Europe or whatever, who knows what those, because here's the cool thing about these panels. The actual cost is the setup. After that, it's largely free. Once you get the computers in the households and the households recruited, you can do lots of surveys. So the real cost is not actually each data collection. So that's why they can negotiate prices. We want them to stay in business, but they don't need to make that much profit.
Great, fantastic. Okay, well, let me turn it over to the group, and I think Bingju is our mic runner today, so questions from the crowd. Let's go. Start with Will.
Thank you so much. As someone who's followed this topic, I was pleased to be surprised by some of the things you told us today. One of the most surprising things was, it seems based on what you presented, that the whole weighting procedure, that I was very surprised that doesn't even work on average, and I'm curious, do you think that's because there's low-quality data being fed into the model, or some other assumption of the model isn't satisfied by the people using it? Because I trust the people who built these post-stratification methods. So where's the breakdown?
Okay, so another ad for Stanford, and this is for a guy named Matt DeBell. Matt is the director of the National Election Studies staff at Stanford, and he wrote a memo after a very heroic effort to identify optimal methods for post-stratification to build these weights. And so that memo is online, you can see that. Josh Pasek, who also got a PhD here, is now a tenured professor at the University of Michigan, put that into software. It's called ANES Rake. So that's my favorite way of creating these weights. The basic logic for everybody is the following. If you do data collection with a random sample, typically you'll have too many women, not enough men. You'll have too many highly educated people, not enough less educated people. And so the weighting is designed to correct that. And essentially what you do is you just kind of multiply the women by 0.8 and multiply the men by 1.2, something like that, and then the results are a little bit more driven by the underrepresented groups as a result of that. Now, that method with random samples, in my experience, always helps a little bit, and I showed you some of those little improvements today. But the question is, how is it necessarily going to help the non-probability sample surveys, and by how much? So the key is that if I fix the sex distribution, it's only going to change the voting distribution to the extent that sex predicts voting. And it's the same thing for education. So I can fix shoe size, but if it doesn't predict anything, it's not going to change accuracy of other measurements. So that's a key issue, is are you using variables that will fix the other variables that you can't fix? And this is a little bit like the drunk guy looking for his keys under the lamppost even when he didn't lose them there, because what do we weight on? We weight on the variables we can get, and they're demographics that we get from the government. So who said that shoe size is going to be I'm kidding, but is going to be a powerful predictor of vote choice. So first of all, I think we should expect no more than a little improvement. But the problem with the non-probability samples is you can weight up the men if you want to, but they're the wrong men. So it doesn't solve anything to get that variable in line if you don't have a random sample of the group you're trying to represent. So that would be the best I can do to explain that.
Most of your
Use that
comments.
microphone for us.
Most of your comments were about public opinion questions. I'm just curious whether there are random sampling available for commercial use.
Thank you for letting me clarify. Actually, most of the data I showed you were not about public opinion. I mean, the voting we'd call that a behavior, but it certainly reflects public opinion. But the vast majority of the accuracy scores that I showed you had to do with number of bedrooms in your house, whether you smoke cigarettes or not, factual behavioral matters. All of these methods are being used commercially. They're all available for commercial use, and they're all being used.
Okay, we'll go to you next, Matt, but we've got some great questions from online. One of them is something I was going to ask as well. This is partly a story about technology, partly a story about Stanford. Here at Stanford, we have a number of new companies around simulation of respondents. So what are your takes so far on the sort of like simulation era of technology and surveying?
Yeah, so the most extreme version, of course, is to ask AI, if I were to do a survey of a representative sample of Americans and I were to ask them this question, what % of people would answer each way? Wouldn't that be fabulous? How's AI going to answer that question? Well, first thing is go try to find a survey that already did that. And then if you take away all the surveys, now AI doesn't have anything else to look at. So that's the first potential problem in the long term. But in the short term, the real issue actually comes back to your weighting question, which is, if we take things I know about the public, how well can I predict things I don't know?
Right.
And the answer is, I don't know about, I think your experience is probably like mine, like a big R squared in a regression is like 0.25.
Yeah.
So we're just, with all the weaponry we can get, we the scientists are just not that good at using variables we have to predict other variables, unless you cheat, basically. Like if you say, did this precinct vote for the Democrat or the Republican in the last election? Turns out when you have presidential elections and you look at a variable like voting, that is very consistent over time. So yeah, as you said, sticky.
What if you use it in a different way, not asking AI, hey, tell me what you think the answer is going to be, but rather like, hey, AI, you're John Krosnick, you're this, somewhat of an agent-based approach where you have 1,000 simulated people.
Yeah.
Do you have any thoughts on this?
Yeah, I mean, I can't cite research that I've seen that gives me confidence in that, and it's kind of the same issue. It's actually even harder, right? Like probably predicting aggregates statistically is easier than predicting individual, and it's going to be the same regression equation either way.
Yeah.
So I'm not optimistic.
Okay. One last question. We'll go to Matt from the thing. This is something that was on my list as well. Prediction markets are a huge topic right now, likely to be listed on the stock market. I was thinking about it when you were talking about, like, if you aggregate a bunch of garbage, you don't get anything better. There's some wisdom of crowds thinking that is actually betting against that in a way. So do you have a take on these sort of markets? I mean, they're putting money where their mouth is, I suppose. So what is your take on the prediction markets?
Yeah. So there are prediction markets, predicting election outcomes, right? So if you were going to bet, if I said, could you please bet in the midterms, is there going to be a flipping of the Congress? Well, if you're smart, one of the first places you're going to look is polls. And if you look at polls, then you're going to be even better off if you can differentiate the crappy polls from the good ones. Mm-hmm. And then you make your bet. And so there's every reason to imagine that well-informed people who are in betting markets will do well if they're basing their predictions on the polls, and they might even be better than one poll at a time if they put the right ones together. Yeah. So I'm not anti that, but my guess is, to say the betting markets are better than the polls. And sorry, they're not independent.
Right. It's because they're drawing on the polls.
Exactly. That's what I would say. If you're not, then they certainly should be. They do even better.
Mm-hmm. And so it's not about the fact that there's like money on the line. It's not just them throwing stuff out like the online river sampling. This is like I lose if I'm wrong.
Well, that gives them the incentive to be smart about the polls as they use them. I mean, bear in mind, there are about 12 or 15 political scientists who have developed prediction equations, and they'll, like 300 days before the election, they'll predict which party is going to win the next presidential election based on information that's available at that time. There's 300 more days of polls that they don't have to make those predictions. Some of them are accurate, some of them are not.
Okay, great. Matt.
Thanks for a really great talk. I wanted to ask a little bit more about the death knell, as you said before, about sort of AI bots and the online surveys. So I also saw Westwood's paper. It's really interesting. One of the first reactions that I had was like, there's some sort of level of technical ability that comes with basically being able to do that and build that. And I'm sort of imagining kind of a trade-off. Like, okay, if you're capable enough to do that, will you bother to put the time in? And so I can imagine you've got these like click farms that are sort of trying maybe to build these kind of big things. But like, from your understanding or whatever else you've seen in sort of literature, is this like a problem that's a current problem where everything's going to be bots immediately, or will it take a little while? Will somebody build like a bot you can purchase that you can then roll out on these survey platforms? Like what does that look like in terms of like what's the actual death knell as it sort of rolls out into the world?
Yeah, thank you. I guess I would say some part of me would love for Sean to create a company, and so that he sells his bot to other people, and then they unleash it on the opt-in survey companies, and then we kill off the opt-in survey companies. But the problem is that if enough people learn about the bots, and then like the knowledge panel recruits them, they think, oh, I could answer quicker and make my money that way. So I don't have a happy picture exactly of how this goes. But what I can tell you is, as I said before, the companies are already trying to defend against him, and I hope that he will go the next step to show that, let them say they've got it fixed, and then do the test and see if it's really fixed. And I don't know, AI seems pretty smart. So, and if I had to bet on that, I would bet on the AI side of it. So, when does the damage stop? Not exactly clear. But the one thing that I think is really heartening in all of this is that, you could imagine in 2016, when the disaster happened in the front and center spotlight, like every American knew about this maybe, I thought for sure like the world was going to give up on polling. It hasn't happened. The appetite for understanding where people are and where they're going to be is gigantic. So we got to get it solved on our side, and that's what Caesar is about, and I hope that we can do that well.
Cool, thank you.
Let's end on a note that's sort of related to what Matt asked you. So this comes from online as well, which is, again, we're here in Silicon Valley. Is there a possible entrepreneurial solution here that allows you to get accuracy and the scientific sort of method alongside some kind of reduction in costs and accuracy, speed, and affordability? Is there an entrepreneurship, or is it's just not possible to get all three?
Well, the example that comes to mind for me is what's called blended samples. So the notion was that maybe what we could do is just administer the questionnaire to a very small number of respondents from a probability online sample, and then buy a large number of respondents from a non-probability provider, and weight the latter group to match the former group, and then we could solve the problem. It'd be a lot cheaper to pay for these other people than the expensive group. And I'm not going to surprise you if you compare an entire probability sample to an entire non-probability sample to a blend. The blend is in the middle, and so you can't make the inaccuracy go away entirely.
Gotcha. Great. Well, on that happy note, just kidding. Thanks for sharing about the new center, Caesar, and we'll make sure everybody can get access to that link. And thank you, John, for being here with us. Please join me in thanking John Krosnick for sharing everything with us. And next week we have, Ben, I'm sorry I didn't memorize it. Maybe Sunny could tell me. There we are. Peter. Peter Norvig, who is, a founding figure in the world of AI, and really excited to have him here. I know that I've used his conceptual definitions of AI for a long time, and just really excited to have him come and visit. So stay tuned then. Please join me again for thanking John. Appreciate it.